So last video you guys saw what are the principles of Huygens, basically how the wavefronts actually come and they hit the surface. So in this video you'll be seeing how wave theory of light could explain reflection of light. So when we talk about reflection, main thing is angle of incidence should be equal to angle of reflection. This is what we are going to prove. Now, if you look at the figure, so what we have is, consider this to be Mn. Mn is the reflecting surface and a ray of light is incidenting, let's say at some point A. Okay, and then it's reflecting. Now, let's say B, this point is B. Now, AB will be a plane wavefront which is reflecting. So, AB is the incident wavefront, we can say. Okay, AB is the incident wavefront. Now, if you look at this, see there is one more ray of light coming here. So, this is C. Now, BC will be the another wavefront which is coming. So, C to, let's say, this point E. Now, CE will be the reflected wavefront. So, what we have is, we have AB to be the incident wavefront and CE to be the reflected wavefront. Okay, so keep this in mind. Now, how we got the CE? That's a very important point. See, what we do is, if you look at the figure, now see the velocity of light, let's call it as V, and it is taking some time t to come and hit the surface. Okay, so then BC distance will be V into t, right, because it's the distance. So what we have here is BC will be equal to V into t. Okay, now we take same V into t as the radius and we draw a circle, basically an arc, keeping A as the center, and then you join that particular point to C. So basically CE is the tangent, don't you think? Right? So what we get from here is BC and AE are equal. So this point is very, very important. So we have BC is equal to AE. This plays a very important point. Alright. So then what we have is, this is angle I, angle of incidence. Now if you look at this, if this is angle I, even this also will be angle I, correct? Okay, now AB, whatever you have, that's perpendicular to the incident wavefront, correct? So if this is I, then the whole angle, that means this whole angle will be 90 minus I, right? So if that is 90 minus I, then even this angle will also be angle I, correct? So this becomes I. Now similar way, this angle will be R, because CE is the reflected wavefront, right? So this is R. Now if you look at the figure, this is 90 because it's perpendicular and CE is tangent, so even this will be 90. So if you take the two triangles, that is, if you take triangle ABC and triangle CAE or CEA, if you take these two triangles, 90 degree, correct? So we have we have BC is equal to AE. This we have constructed in such a way that BC is equal to AE is equal to V into T, the distance covered by the wavefront. Okay, this is one. Next, we have angle E to be equal to angle B, both are 90 degree, correct? And we also have AC to be common, right? So both the cases AC is common. So if you look at this, you can use RHS postulate. So these two triangles are congruent. So what we have is, therefore triangle ABC is congruent to triangle CEA. If this is the case, then I will be equal to R, correct? So we have I is equal to R. So what we concluded from this, is these two triangles are congruent. So angle of incidence is equal to the angle of reflection. So this is what we have to conclude, or how wave theory could prove the reflection of light. And one more theory was the angle of incidence, the incident ray, the reflected ray and normal should be in the same plane. If you can look here, the incident ray or the incident wavefront, the reflected wavefront and the normal, all three are in the same plane. So wave theory could explain how reflection of light could happen. So in the next video, you will see how refraction happens.